We start with ones going this way and then ones on the other side. If I saw this one.
Some
Okay.
of those is
Yeah. So we have ones going this way,
Yes, 1, 2.
and then we have this essentially. So, well, guess what? Lo and behold, this is actually right out of, once again, Virahanka's work. And he describes it in chapter 6, verses 10 and 11. And I have the Sanskritam with me, but since I suspect most of you don't speak it, I will read you the translation. So this actually I read in the book just a few days ago after my exams were over. There's a modern publishing actually of Virahanka's work by Rajasthan Granthamala series that comes out of Rajasthan, India. So you can actually get a copy of the book. They're a bit old. I think they were last printed, like the last printed ones were in 1950. So we have a copy of that at Princeton that we may have somehow acquired. So the translation of what he says is, make 2 boxes in the first row. So make 2 boxes. Maybe I'll get rid of this stuff at this point. Make 2 boxes in the first row, 3 below, 4 thereafter, and so on. So he wants you to do this. And if I was better at making boxes, they would look good. Fill in the first and last boxes with ones, and then fill in empty boxes with the sum of the boxes above them. This is the meru that subsumes the suchi. So that's what he says. So he calls this, so if we do it, we get the same thing. We add these, add these, add these. And this is called meru prastara. And this is also attributed to Virahanka, is attributed to Pingala by Virahanka. So this also presumably originated at least in the 4th century BCE or before. And surely before the 8th century CE, which is a good 800 years before Pascal at least. And as you heard from the translation, he says this is the meru which subsumes the suchi. So suchi is another type of prastara that he discusses, which is an answer to another grammatical question, which essentially ends up having the same answer, but produces exactly 1 row of this. So that thing is called suchi prastara. And sort of finishing up with Virahanka's work over here, these are just a few of the things that he talks about. There are many more things which I will hopefully have time to read about while I still have access to the book before I get out of Princeton. But he talks about at least 7 prastaras of this nature. These are 2 of them. And that's just this one man and his one work. So moving on from, so this is all in the field of combinatorics in mathematics. And up till here is the end of the stuff that I have read myself. And I'd like to leave you with one other piece of mathematics from slightly later in the Indian canon, but nevertheless a very important precursor to some mathematics that we study, and that is in calculus. So the famous Indian mathematician that's known for his calculus is Madhava of Sangamagrama. Who is approximately 1340 to 1425 CE. And he's from the Kerala school of mathematics, so in South India, on the west. side. And he did some work that is in calculus, and this predates Newton and Leibniz. And some people believe that it's possible that because of the trade route from India to Europe, some of this work was transferred up to Europe and helped in the generation of what we study today, the common calculus that we study today in like schools and colleges. So in comparison to Madhava, Newton is 1642 to 1726 and Leibniz is 1646 to 1716 CE. So about a couple hundred to a few hundred years before. And Madhava essentially states the following formula for approximating pi through an infinite limit series. So the formula he states is this: pi over 4 equals limit n tends to infinity, sum k equals 0 to n, negative 1 to the k, 2k plus 1. This is not how he actually writes it. This is modern notation of what he writes. And to get an idea of what this actually looks like, he's saying that it's actually just this. So 1 minus 1/3 plus 1/5 minus a 7th plus a 9th, etc. So this alternating series is equal to pi over 4. The stuff that I showed to you before, maybe you could imagine coming up with it, given some time oneself. This thing, unless there's some very great mathematicians out there, it's a pretty crazy formula that is hard to derive. And we do not know exactly how he derived it, but he states this formula and it happens to be correct. And he's famous for not only this, but a bunch of other infinite series, including other series for pi that converge even faster. So something that people have always been interested in is pi is an irrational number that has many decimal digits after the dot, well, infinitely many. And so you want to get as many of them as you want accurately. And so in days before like computers where calculations were slower, you wanted to come up with infinite series that converge very quickly to pi. So that if you just calculate the sum up to this point, for instance, you can get pi up to like 10 decimal digits or something, or maybe more. So he was one of the big mathematicians of the time who was working on this problem. And in his time, I think he has the record for the most number of digits that were given. And he gives them in the form of a poem. So if you want to know more about this work, Professor Ramasubramanian at IIT Mumbai has some good videos about this, and he's working on this. In fact, yeah. So yeah, in fact, I have a friend who is essentially interning with him over the summer. Some of you might know him, Siddhartha Jagannath. So he's, you know him. Yeah, that's a prerequisite to study ancient mathematics. No. Yeah. So Siddhartha was actually he was brought up for the most part in the U.S. And he's also been moving between here and Tamil Nadu. And he is a prolific Sanskritam speaker from the Samskrita Bharati community here. And he's currently also studying Panini. And he's doing an internship in this stuff. And if you ever run into him, a great guy to talk to about ancient India. So that's all I have for whatever I'm doing up here. Yeah. Is that a hand?
Oh, no.
No. Okay.
Isn't so Srinivasa Ramanujan, who was the movie The Man Who Knew Infinity, the
Right.
movie that came out last year, whatever. I think that he does refer to Madhava because they're from the Kerala. He's
Right,
part of
right.
his ancestors. So there's a reference to that. When I was doing some research on contributions of ancient Hindus, Madhava school of the Kerala school of mathematics came up.
Right, yeah. The Kerala school is like very famous. But unfortunately, it's not famous in like what we popularly teach in Western academia.
Nothing is famous. There are so many. Aryabhatta is not taught in mathematics.
Yeah,
How much
yeah.
Aryabhatta is taught? And he's the most famous, supposedly, right, of all the mathematicians of India.
Right. So I guess that's one unfortunate thing that happens in academia, that the contributions of people outside of the Western canon aren't often recognized. And that's one thing that me and Manjul think should also like change, and hopefully we'll get some traction there.
Yes.
Siddhartha, I have a task for you.
Yes.
You're going to MIT, right?
Yes.
Look at all the top of the buildings, main campus. You will see only the Western recognition of Western mathematicians. You will not find even Bhaskaracharya or Siddhartha. So you have a task.
Make them well recognized.
At least have Aryabhatta here.
Yeah.
Instead of putting a police car on top of the dome,
Just go to the top of the dome and like,
MIT is all about their pranks.
yeah, I could get some people to do that.
No, you don't have to do all this. Some
Yeah.
have to initiate a process that each should be recognized.
Yeah.
The source should
Agreed. I also noticed this in like other disciplines that are taught at like Ivy Leagues. For instance, I took like political theory, and the only political theory we talk about is like stuff that came out of like essentially Western Europe after like 1500 CE, which is really ironic because it's reasonably well known that like the countries with the highest GDP until like 1500 or even 1800. Like until about 1500 it was India, after that it was China for a bit, after India was under invasion. And so there's an obvious reason to be studying like the economic and political and social means through which they were able to achieve those great heights. And it's sad that like, for instance, like Chanakya's Itihasa or something is not taught widely in like a political theory class at Princeton or something like that. And I guess partially the problem is that the professors who teach don't know about it. And partially the problem is that they don't seem to care to learn about it. Which is sort of sad, but yeah.
People learn about the civilizations that best represent themselves. So
Yeah.
there's work for us to do as well.
Agreed. So that's what I have up here. Do you want to break into some type of discussion, or are there any questions about anything that I said?
Yeah, no, this is fantastic.
So I guess it depends on the tone of the room. So I know that this was very presentation based, so we have time that